All right, let's finish this thing off. Now we're going to talk about theoretical versus experimental. Is it a bad theory or is it a bad experiment, or is something bad going on? Something is happening. If the numbers don't line up, something is happening. So the theory and experiments should be close. If not, something is or went wrong. So let's go back really quick before we do anything else. Let's go back to these problems right here, okay? So right now, I am completing 75% of my passes. So the probability of my next drop would be about 25%. Okay. Now, out of the next 50, if I were to continue my 75% completion, I should complete about 38. So that's what should happen. Now, out of the next 50 passes, what happens if I complete 10? Whoa, dude, you're way off. You should have completed 38. You only made 10. That's really, really bad. Your percentage went from 75% to 10 out of 50. That's 20%. You went from 75% to 20%. What in the world happened? Or vice versa. I should have made about 38%, completed 38%, but let's say I completed 48. Dude, you're on fire. You, out of 50 passes, you made 48. That's amazing. Okay, so trends. Do the numbers stay the same or do they change? That's when we start making observations or making analyzations. I think that's the word it is now. We start saying, dude, something changed. Something is not lined up. It's something is not the way it used to be. So what in the world happened? And so we can use those happenings to predict things. All right. So here we go. So here's an example of something I think that works out pretty good here. So I flipped a coin 40 times. The results, I have 21 tails and 19 heads. Okay. So in theory, it should be 50-50. Okay, we talked about that early on, okay? So what were the results? The results, I had 21 out of 40 and then 19 out of 40. So 21 and 40 are about the same number. Sorry, 21 and 19 are about the same number. But let's go ahead and compare. So 21 out of 40, really quick little calculations here. 21 divided by 40 is 52.5%. So I should have gotten 50 and I got 52.5%. Pretty close, okay? So if that was 52.5, that means this should have been 47.5%, okay? So this one got an extra 2.25%, and this one got it taken away. So together they should add up to 100%. Anytime you take your results and your results don't add up to 100%, that means you must have missed something. You did some bad math, okay? So here's what should happen. Here's what did happen. Pretty darn close. We all know in real life things don't always go exactly to plan, but they should be pretty close. Now, if I were to give every single student a penny and I had every single student flip it 40 times, the fact that if it was perfectly 20-20, that actually would be kind of rare. Okay, so there's a whole other facet of this, what's the probability that all of your students got 20 out of 20? It would be just insanity. So that's a whole other facet of probability we're not going to get into, okay? Just know for now, this is good, okay? Pretty darn close, pretty darn close. Again, life and theory don't always exactly equal each other, but they should be pretty darn close. So here's a good one. I like this one. I made this one up on the spot. I remember this from an old school math problem in an old textbook, so something kind of like this. So here's a diagram of Highway 20. Here's exit A, here's exit B, here's exit C. Between exit A and exit B, it's 18 miles. Between exit B and exit C, it's 32 miles, okay? So here's the math. If accidents happen at random, what's the probability an accident would happen along this stretch? Okay, well, the entire stretch is 50 miles, so the probability that an accident would happen from exit A to exit B, there's 18 miles. Oh, my marker is running low here. There'll be 18 miles out of 50 possible miles that could happen, okay? B to C would be 32 out of 50. Okay, I made these nice because I wanted to have nice percentages here. 18 out of 50, I believe that's 36%. Okay, and then 32 out of 50 is 64%. They add up to 100? Yeah, they do. Okay, so there you go. So this is what should happen. If you were to get in an accident, or not you, but anybody, if an accident were to occur along this highway randomly, there's a 36% chance it'll happen here. I'm going to write that right here. 36% chance it'll happen here, and there's a 64% chance it'll happen here, okay? That's if accidents were equally likely to happen anywhere. Now, let's say we pull up some accident reports. So from 2012 to 2018, the last 6 years, there's been 41 accidents between A and B, and there's been only 29 from B to C. So let's find the relative frequency of that, or the probability of that. So let's see, total accidents. Let's see, I don't think I made this one be super nice. Let's see here. 41 plus 29 is 70. There's been 70 total accidents, okay? So watch this, I'm gonna cheat a little bit. 41 out of 70, 29 out of 70. So right away, there's more linked up with a less percentage, and there's less linked up with a higher percentage. So right away, your instinct should be saying, whoa, 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 something is not right here. Yeah, I totally agree. Let me switch colors here. Let's do the accident frequency. Let's see, 41 divided by 70 is about 58%. We'll go to just a regular percentage. So about 58%. Sorry, this marker's a little fat, my bad. And then 29 out of 70 is about 41%. Okay, so oops, I did 41 out of 71. Whoops, so that should be actually 59%. Whoops, there we go. Now it adds to 100%. There we go. Wow, I'm just screwing this all up. There we go. So yeah, 59%. Sorry, you can't read that. So 36% should happen, and then 59% actually happened. Okay, 64% should happen, and then 41% did happen. Yikes, that's not good, friends. These numbers don't line up. There's something going on. 59% of the accidents are happening here when 36% should be happening. Something's not right, okay? So there's something wrong. So if I were let me make this up, a highway safety engineer dude, okay, I would say, whoa, there's something wrong here. So there's something wrong with the road. Is there a distraction? Is there, I mean, this is just a diagram, but is there like a curve? Is there an interchange, another interchange, an overpass? Is there something? There's got to be something here that's causing this type of discrepancy, because they should somewhat line up. In a perfect world, there should be no accidents, but humans are humans. But there's something going on here. So I would analyze these numbers. I would make an adjustment, keep more data over the next few years. Hopefully no more accidents would happen, but you would kind of hope the numbers would align over time, okay? So that's kind of what the whole point of experimental versus theory. Something's wrong. If the numbers don't line up, something is wrong and it needs to be fixed. Okay, and then keep in mind, you know, when humans are involved, there's only so much you can fix, I suppose, but that can be a conversation for another day. All right, that's it, friends. We'll see you in class. Goodbye.